Good afternoon, all. Am I audible? Hello?
Yes, ma'am.
Okay. So last lecture we have started with the lattices. In that we have seen definition of lattice, how to recognize whether a given diagram is lattice or not. So in that we have seen lattice is a partially ordered set in which for every two elements there should be only one greatest lower bound and least upper bound. After that, we have solved many examples based on lattices. So today also, I think last lecture I have given one exercise. Some examples you have to solve it. So that question was given as sets are given, that is S6 means what, 6 is the integer, and here you have to find all the divisors of 6. So if you consider this example S6, here we have to write the divisors of 6 like 1, 2, 3, 6. Okay, so we can draw a four-set, that is has a diagram for this one or lattice for this set as 1, 2, 3, 6. Why we have placed these elements in this order only? Because here a relation is given as divides relation. So 1 divides 2, 1 divides 3, and both 2 and 3 divides 6. That's why lattice will be like this. So again we have to check whether each and every pair of elements have only one greatest lower bound and least upper bound. So here we are going to consider the pair of elements 2 and 3. So greatest lower bound for these two elements 2 and 3, it is represented as 2 star 3. So value for this greatest lower bound is 1, and least upper bound for these two elements, that is least upper bound of 2 comma 3, that is represented as 2 XOR 3, and its answer is 6. So likewise again you can consider the pair of elements 1 2 1 3 2 6 3 6. So again if you consider 1 2, the pair of elements 1 2. So what is the greatest lower bound in this case? 1.
One.
And least upper bound, it is, yes, 2. So likewise we can find
One.
greatest lower bound and least upper bound for each and every pair of elements. That's why we can say that this is a lattice. So likewise the next example, it was given as S24. So here we have to find all the divisors of 24. So here I have listed divisors like 1, 2, 3, 4, 6, 8, 12 and 24. So now you have to try for lattice. So take time of 5 minutes and draw lattice for this example. Again, you have to consider each and every pair of elements, and you have to check whether there exists only one greatest lower bound and least upper bound. Then we can decide whether whatever lattice we have drawn, that is correct or not. So are you able to draw this lattice?
Yes, ma'am.
Okay. So try it and send your answer on our WhatsApp group. So I can check it whether whatever you have drawn, it is correct or not. So we will see solution for this example. We can draw the lattice like first element is 1, that is placed here. 1 divides 2 and 3. So 2 and 3 are written here. Then 2 divides 4, 4 divides 8. And here 3 divides 6, 6 divides 12. Also 4 divides 12, that's why this line is given. 2 divides 6, that's why this line is given. And then for this 24, both 8 and 12 divides 24. That's why our diagram will be like this. So here we can consider the pair of elements. Those are not connected by direct lines. So what are those pairs? So first pair we can consider 2, 3. So greatest to lower bound for these two elements it is 1 and least upper bound it is 6. So again we can consider the second pair of elements and that is 4, 6. So here the greatest to lower bound is 2 and least upper bound is 12. And just one more pair is there, that is 8, 12. So for this pair greatest to lower bound is 4 and least upper bound is 24. So here we can say that there exists only one greatest to lower bound and least upper bound That's why this given diagram is a lattice. So likewise, we have to find the next one for S8. So here an integer given is 8. So first of all, we have to find what are the divisors of 8. And those dividers are 1, 2, 4, 8. So now we have to draw lattice for this diagram. So first element is 1. 1 divides 2, 2 divides 4 and 4 divides 8. So here all the elements are placed in line. That's why we can call this one as torset also. Already we have seen this concept in unit number 4. If the set of elements forms a chain or a straight line, then that one is called as torset. So again, we can take any pair of elements, and for that we can find out greatest lower bound and least upper bound. So here I have considered one pair 1, comma 8. So for this pair, greatest lower bound is 1 and least upper bound is 8. So likewise, you can take order pair as 1, comma 4. So for this pair, you can take greatest lower bound as 1 and least upper bound is 4. So in this way, we can find both the bounds like greatest lower bound and least upper bound. That's why this is a lattice. Now, for the next example, we have to try. So first of all, draw a lattice for this given example. Here, value of an integer is 30. So first of all, we have to find the divisors of 30 like 1, 2, 3, 5, 6, 10, 15 and 30. So now you have to draw lattice for this example. So try it. Already, I think in Hasse diagram, we have seen this point. We have already drawn this diagram, but still we have to draw it for lattice. Yes. Have you tried for this example? I got one reply, but here whatever you have drawn, that is not correct because 2 is not divisors of 5 and you are directly connected 2 and 5. That is not correct. So this solution here first integer is 1, 1 divides 2, 1 divides 3 and 1 divides 5. That's why we have placed all these three elements in this fashion. Now next one is 6, but for this 6 there are two divisors 2 and 3. That's why 2 and 6 are connected by direct line and 3 and 6 are connected by direct line. Now next one is 10. So for this 10, two divisors are there 2 and 5. That's why these are connected by direct lines. Next one is 15. So for this 15, 3 and 5, these two are divisors. And last number is 30. So for this 30, all 6, 10, 15, all these are divisors of 30. So this diagram becomes like this. So now we have to check for greatest lower bound and least upper bound. So first pair of elements I have considered as 2, 5. So greatest lower bound for these two elements is 1 and least upper bound is 10. Now if you consider 3 and 5, greatest lower bound is 1 and least upper bound is 15. So again if you consider the pair of elements 6 and 10, then greatest lower bound is 2 and least upper bound is 30. If you consider pair of elements 6 and 15, greatest lower bound is 3, least upper bound is 30. Again, if you consider pair of elements 10 and 15, so what would be the greatest lower bound?
5.
5, correct. And least upper bound, it is 30. Yeah, 30. Yes. So here again, greatest lower bound and least upper bound exist for each and every pair of elements. That's why this is lattice. So likewise, we can draw a lattice. Have you understood these points? Yes. Do you have any doubt? Okay. So now we are going to see the next point, that is properties of lattices. So up till now we have seen what is lattice and how to draw a lattice. Now we have to see what are the properties of lattices. So here total 8 properties are given. So these properties are denoted by two symbols. First one is star, that is for greatest lower bound, and next one is XOR. So some of the properties of two binary operations of meet and join denoted by star and XOR on lattice L partially ordered relation for any ABC belongs to L. In short, here L is a lattice and on that lattice we have defined one partially ordered relation and ABC. These are the three elements of that set L. Okay. So let us see first property, and that is idempotent property. So that is given by L1. So A star A, that is equals to A. This is the property for meet operation, and second one is A XOR A is equals to A. This is the property for join operation. So first property is denoted by L1, second property is denoted by L dash 1 complement. So these are the two operations. So first one is denoted by original operation and second one is denoted as its complement. So just you have to remember the lattice satisfies idempotent property. So if we consider any element A, then we can write greatest to lower bound as A star A is equals to A. If you consider least upper bound, then A XOR A, that is equals to A. Now we have to see how this proof becomes true. So here I have written proofs, how to check whether whatever we have written that is correct or not. So consider this example, the first property L1. So what we have written A star A, that is equals to A, and second property A XOR A, that is equals to A. So here consider this element A. In this lattice there is only one element, that's why greatest lower bound and least upper bound for that element will be same element. आता इथे दुसरा कुठला एलिमेंट आहे का? नाहीये. त्यासाठी ग्रेटेस्ट लोअर बॉन्ड काय येणार आहे त्याचा? एच येणार आहे आणि लिस्ट अपर बॉन्ड पण एच येणार आहे बिकॉज देयर इज ओनली वन एलिमेंट इन दॅट लॅटिस. So here we can say that lattice satisfies a idempotent property. Now we have to see second property of lattice, and that property is commutative property. So A star B, that is equals to B star A. This is the for meet operation, and for join operation we can write A XOR B, that is equals to B XOR A. So again we can write proof for this same. So see here. For this second property, that is denoted by L dash 2, A star B is equals to B star A. This what your lattice is containing two elements A and B. Now consider LHS. LHS is A star B. So what is the greatest lower bound for these two elements? A. That's why A is written here. Now we are going to check for RHS. So what we have written in RHS? B star A. Okay. So what is the greatest lower bound for these two elements? B and A. Again it is A. So here we can say that LHS is equals to RHS. So this proof is correct. Now consider for join operation, A XOR B is equals to B XOR A. So let us consider LHS first, and that LHS is given as A XOR B. So what is the least upper bound for these two elements A and B? Again it is B. So that is written here, and RHS is given as B XOR A. So again we have to consider two elements A and B, and for these two elements least upper bound is B. So here we can say LHS is equals to RHS. So in this way we have proved here commutative property, that is A star B is equals to B star A, and A XOR B is equals to B XOR A. Have you understood this proof? Hello? Okay.
Yes, ma'am.
Because based on this, you will get question as write the properties of lattices for 6 marks. So at that time, you have to write this explanation as well. Now, third property of lattice, and that is associativity. So for any three elements A, B, C, we can write meet operation as A star B star C is equals to A star B star C. And second one, for joint operation, we can write A XOR B XOR C is equals to A XOR B XOR C. So here we have changed brackets. So now we have to prove this property, how it is true. We can consider here. So first we will consider meet operation. So for this meet operation, LHS is taken as A star B star C. So first of all, we have to consider a lattice that is containing three elements A, B, C. Okay, those three elements are written here. Now value for A star B. So what is the value for this operation? A star B, that is greatest lower bound of these two elements, and that answer is A. So answer for this whole bracket is A. Now we have to take its star operation with C. In short, again we have to find greatest lower bound for these two elements A and C, and greatest lower bound for this one is A. So value for this LHS, it is A. Now check for RHS. RHS is given as A star B star C. Okay. So check for this bracket. First we are going to solve this bracket B star C. This one, greatest lower bound of B and C, and answer is B. So now we have to take A star B. So again we have to find greatest lower bound of these two elements A and B, and it is A. So check here, LHS is equals to RHS. So we can say that this first statement is correct. These two statements are correct. Now we have to check for second one, that is for join operation. So now consider LHS. LHS is given as A XOR B XOR C. So first of all, we need to find value for this bracket. So what is the value for A XOR B? Is for least upper bound of A and B, and answer is B. Now we have to take its XOR operation with C. So B XOR C is for least upper bound of B and C, and answer is C. So LHS, we got answer is C. And for RHS, RHS is as A XOR B XOR C. So RHS is written here. Now value for B XOR C. So least upper bound of B and C, and its answer is C. Now we have to take XOR operation between A and C. So A XOR C, again it is C. So here we can say LHS is equals to RHS. That's why whatever statements we have written, those are correct. So we can say that lattice satisfies associativity property. Now check for next property, and that is for absorption. So what is this absorption property? A star A XOR B, that is equals to A, and for join operation A XOR A star B, that is equals to A. Now again we have to write proof for this property. So first of all, consider first statement, that is A star A XOR B, that is equals to A. So now we have to prove it. Here LHS is given as A star A XOR B. So first of all, we are going to solve this bracket A XOR B. So what is meaning of A XOR B? Greatest lower bound of elements A and B, and its value is B. So that is written over here. Again, A star B. So A star B means what? Greatest lower bound of A and B, and that is A. So answer for this LHS is A. Now check for RHS. RHS is given as A only. So we can say this LHS is equals to RHS. So here we have written proof for first statement. Now check for join operation. So join operation we have written as A XOR A star B, that is equals to A. Now check for value of A star B. A star B. So here value for this operation is A. So A XOR A. So again we have seen in the first property itself, that is if there is only one element, then greatest lower bound and least upper bound is that element only. So here again only one element is there, A. So if we take its XOR operation with A, you will get answer as A only, and that is our RHS. So again here LHS is equals to RHS. So whatever four properties we have mentioned here, all those four properties are true. So lattice satisfies four properties. First property is idempotent, second one is commutative, third one is associative, and last one is absorption. So there are total four properties of lattices. So this point is very important. Most of time they have asked question on this point for 6 marks or 8 marks. Have we understood this point? Properties of lattices? Hello.
Repeat, ma'am.
Okay. All the properties?
Yes, ma'am. All.
Okay. No problem. So here we have taken four properties of lattices. First property is idempotent property. Okay. Now that idempotent property means what? Again we have to write those properties with respect to join operation and meet operation. So first we have taken meet operation. A star A is equals to A. So this statement we have written for meet operation. So likewise we have to write it for join operation. So again meet and join means what? Greatest lower bound and least upper bound. So this join operation is A XOR A is equals to A. So here just we have written properties. Now we have to prove it whether whatever statements we have written, those are correct or not. So proofs are given here. First property we have to prove. Consider here L1. This is the first property of lattice. That's why L is given. 1 means what? First property. Now here A star A is equals to A and A XOR A is equals to A. So this is idempotent property. First property is, first statement is written for meet operation. Second statement is written for join operation. Okay. Now observe these two statements. Here it is containing just one element, and that element is A. Okay. So if you take meet operation or join operation for this element A, you will get answer as A only, because there is no any another element. The A हा एकच element आहे. त्याच्यासाठी ग्रेटेस्ट लोअर बॉन्ड आणि लिस्ट अपर बॉन्ड हा तोच एलिमेंट असणार आहे. म्हणजे आन्सर काय येईल त्याचा? एच येणार आहे. So if you want to find out greatest lower bond for this A, that is written as A star A. So you will get answer as A only, because there is only one element in given lattice. Now if you want to find least upper bound for this element A, that is written as A XOR A. So again this lattice is containing just one element, so answer is A. जे काय जर तुमच्या लॅटिस मध्ये एकच एलिमेंट असेल तर ग्रेटेस्ट लोअर बॉन्ड अँड लिस्ट अपर बॉन्ड फॉर दॅट पर्टिक्युलर एलिमेंट इज दॅट एलिमेंट ओनली. जर इथे ए च्या जागी बी असेल तर काय येणार आहे? आन्सर फॉर बी स्टार बी. सो value for greatest lower bound of B, it is B, and value for least upper bound of B, it is B, because there is only one element in lattice and that element is B. First property समजली का?
Yes, ma'am.
Okay. Now next property we have written, and that is for commutative property. Okay. So here we have written commutative property for meet operation as A star B is equals to B star A. And here we have written commutative property for join operation as A XOR B is equals to B XOR A. So let us see proof for first statement, that is A star B is equals to B star A. So consider LHS first. LHS we have written as A star B. So now your lattice is containing two elements A and B. So A star B means what? Greatest lower bound of these two elements. So what is the greatest lower bond?
A.
A. So that is written here. So value we got for LHS, it is A. Now check for RHS. RHS is given as B star A. Okay. So again we have to take greatest lower bound of B and A. Again elements are same. That's why value for this greatest lower bound of B and A, it is A only. So that is written here. So again from these two statements we can prove that LHS is equals to RHS, because at both the sides we got answer as A only. So these two statements are correct. Now check for second statement, that is for join operation. A XOR B is equals to B XOR A. So here first of all we will consider LHS. So what we have written in LHS, A XOR B means what? We have to take this least upper bound of A and B. So what is the least upper bound for A and B? It is
B.
B. So that is written here. Now check for RHS. RHS is B XOR A. So again, least upper bound of B and A. Answer is B. So here also LHS is equals to RHS. So we can say that these two statements are correct. So from this we can say that lattice satisfies commutative property. So this is the second property of lattice. Do you have any doubt regarding this property? समजले का कसं
Yes,
prove
ma'am.
करू?
Yes.
Okay. Now next property, that is for associativity. So what we have done here, just we have changed the brackets. So for this we have taken three elements as A, B, C. So first one is for meet operation. So in the first bracket, what we have written, A star B star C, that is equals to A star B star C. Okay. So we have to prove this statement. So let us see LHS. LHS is given as A star B star C. So here we have drawn lattice of three elements A, B, C. So first of all, we will solve this bracket as A star B. So what is meaning of A star B? Greatest lower bound of A and B. So value for this A star B, it is A, and that is written over here. Now we have to take its meet operation with C. So A star C means what? Greatest lower bound of A and C. So what is the answer for this? Again it is A. So that is written here. Value we got for LHS, it is A. Now check for RHS. RHS is written as A star B star C. So first of all, we have to solve this bracket B star C. Okay. So value for this B star C is, what would be the answer? Greatest lower bound for B and C.
B.
B. So here we have written B. Now we have to take greatest lower bound of A and B. So A star B. So greatest lower bound is A. So again here LHS is equals to RHS. So here we have proved first statement and that is for meet operation. So likewise we have to prove for join operation. So let us consider LHS for this join operation and that is in bracket A XOR B XOR C. So first of all we will solve this bracket A XOR B. So what is meaning of A XOR B? Least upper bound of A and B and its value is B. So again we have to take XOR operation with C. So B XOR C. So it means least upper bound of B and C and value is C. So value for LHS it is C. Now check for RHS. RHS is given as A XOR in bracket B XOR C. So again we have to solve this bracket first. So B XOR C is what? Least upper bound of B and C and its value is C. Again we have to take its XOR operation with A. So A XOR C it is C. Now check LHS is equals to RHS. So for both meet and join operation we have proved this. That's why we can say that lattice satisfies associativity property. Have you understood this property?
Yes, ma'am.
Okay. So now just one property is remaining and that property is absorption. So A star A XOR B that is equals to A. This is statement for meet operation and second one is for join operation that is A XOR A star B that is equals to A. So first of all we will prove this meet operation that is A star A XOR B that is equals to A. So let us consider LHS. LHS is A star A XOR B. So first we will solve bracket as A XOR B. Value for A XOR B it is B. So that is taken here. Again A star B. So greatest lower bound of A and B. So here answer is A. So value we got for LHS it is A. Now check for RHS. RHS is given as A only. So again here LHS is equals to RHS. That's why this first statement is true. Now we have to check for second operation and that is for join operation. So consider LHS. LHS is A star, A XOR A star B. So first we will solve this bracket as A star B. So value for A star B it is A that is written here. Again we have to take its XOR operation with A. So again A XOR A it is A because we are seen in first property that is a idempotent property. A star A value is A. Again A XOR A again its value is A. So here LHS value is A. Again RHS it is A. So LHS is equals to RHS. So whatever statements they have written for absorption property, those are true. So in this way, lattice satisfies four properties. First property is idempotent. Second one is commutative. Third one is associative. And last one is absorption. So do we have any doubt regarding all these four properties? समजले
Yes,
का?
ma'am. Yes.
Okay. Yeah. Good. So today we will stop here. Next points we will see next lecture. So before that, just give me presenting. Roll number 1,
Yes, ma'am.
2. Roll number 2, 3,
Yes, ma'am.
4,
Yes,
5.
ma'am.
Roll number 6, 7, 8, 9,
Yes, ma'am.
10.
Yes, ma'am.
Okay. 11,
Yes, ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Yes, ma'am.
15, 16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20, 21, 22,
Present, ma'am.
23, 24,
Present, ma'am.
25,
Yes, ma'am.
26, 27,
Present, ma'am.
28, 29,
Yes, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34, 35,
Present, ma'am.
36, 37, 37 present. Okay. 38,
Present, ma'am.
39,
Yes, ma'am.
40,
Present, ma'am.
41, 42,
Yes, ma'am.
43,
Present, ma'am.
44,
Present, ma'am.
45, 46,
Yes, ma'am.
47, 48,
Ma'am, 45 is present.
45 present. Okay. 48, 49, 50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, present. Okay. 55,
Yes, ma'am.
56, 57,
Yes, ma'am.
58,
Yes, ma'am.
59, 60, 61, 60 is present. Okay. 61, 62, 63,
Present, ma'am.
64,
Yes, ma'am.
65, 66,
Present, ma'am.
67,
Present, ma'am.
68, 69, 70, check for option numbers. Row number 2, 5, 6, 7, 8, 15, 20, 23, 28, 34, 36, 41,
Ma'am, 36 present.
36 present, 41, 42, sorry, 47, 48, 49, 52, 53, 56, 59, 61, 62, 65, 68, 69, and 70.
Hello.
Yes,
21, ma'am.
21.
Huh?
Yes, I have marked as present. Okay. Thank you. So today we'll stop here.